Okay, so this is the review for number 4. And the first problem says find the limit as x approaches infinity of 5x cubed plus 18 over 20x squared plus 10x plus 9. So this one, all you're going to do is compare the top to the bottom. And since it is bigger on top than on the bottom, it'll be dne, but which is also infinity or negative infinity. And since it says x approaches negative infinity, if you plugged it in on the top and bottom, you'd get a negative number on top and a positive number on bottom. So it's going to be negative infinity. So that is why the answer is E. Number 2 says the equation of the tangent line to the graph of y equals negative 2x squared plus 2x plus 3 at the point where x equals negative 1. So this says the tangent line, so you're going to take the derivative, which I did right there. So when you take it, you get negative 4x plus 2. And since the derivative is your slope, you're going to know that your slope is 6. So then you go back over here on this side, and you're going to plug in the point negative 1 into your equation. So y minus 1 equals 2 times negative 1 squared plus 2 minus 1 plus 3. And that is to get y, which is negative 1. So right there. And then when you plug it into your equation for the line, it's y plus 1 because it's y minus negative 1. And we're right here right now. And then equals, and you just find your slope over here, which is 6. So you're going to put 6, and then parentheses x plus 1 because it would be x minus 1. And then you end with y plus 1 equals 6x plus 6. And you can just leave it like that, but I simplified. It's because we need one of our options, which was B. Find, okay, I'm going to fix that red line. Okay. Find f prime of x when f of x equals x squared over cosine x. So you're going to have to use the quotient rule right here to take the derivative. So I did f prime of x equals, and then derivative of the top always comes first. So 2x times cosine x, because that's the bottom, minus, and then it's negative sine x, because that's the derivative of cosine x, and then times the top, which is just x squared. And then when you simplify that out, it's 2x cosine x plus sine x, x squared over cosine x squared, which is C. Okay, and number 4 reads, what is the x-coordinate of the POI on the graph of y equals 1/3 x cubed minus 5x squared plus 16? So POIs occur when the second derivative equals 0. So all you're going to do is take the first derivative, which you get x squared minus 10x, and then when you take the second derivative, as we did right here, you're going to get equals 2x minus 10, set that equal to 0, and you should get x equals 5. So that is why we get A. Okay, so we're going to skip number 5 because we don't have to do it. And we're going to go to number 6, which says let f of 3 equal 0, and f prime of 3 equal 5, g prime of 3 equals 2, and g prime of 3 equals 1/2. And it says find f prime of 3 if f of x equals f of x over g of x. So since you're going to find f prime of 3, you're going to be taking the derivative. So you can just plug in f prime over, so like right here you could plug in, right here you're going to plug in f prime of x over g prime of x because you're going to be taking the derivative. And we know those answers are 5 over, and then g prime of x, which is 1/2. So then when you use the quotient rule, you're going to take the derivative of the top times the bottom. Okay, so you just took the derivative of f prime of 3, which is 5, and then times just the normal bottom, so 2, and then minus, and then you're going to take the derivative of the bottom, which g prime of 3 is 1/2, and then when you take the derivative of the top, it's just going to be 0, or just, normal f of 3 is 0, and then when you simplify, you get 10 minus 0 over 4, equals 5/2. So you know your answer is B. Okay. Number 7 says find all the intervals on which the graph of the function is concave upward. Okay, so we know that when the double derivative is positive, is concave up. So I just took the first derivative, which is 6x squared minus 12x cubed, and then I found the bottom derivative, sorry, not the bottom, the second derivative, which is 12x minus 36x squared, which we see right here. And then when that's positive, the only answer that works, so when it's greater than or equal to 0, is 0 and 1/3. So I just plugged in, and that was the first one I plugged in, and it turned out to be positive. Whereas the other ones will not give you a positive answer, so you know it won't be concave up. And then we skip number 8, and then we get to number 9, which says the maximum value of the function f of x equals x to the 4th minus 4x cubed plus 6 on the closed interval of 1 to 4 is. So you're just going to take the derivative, and you see that you have points at 0 and 2 once you take the double derivative and everything. And then you're going to find of the function where it's the largest. So I just took 1, 2, 3, and 4 because 3 was one of our values, but 0 isn't in the domain. So then when you plug these in, you see that if you plug in a 1, you get a 3, negative 10, negative 15. And then finally when you plug in a 6, or when you plug in a 4, you get 6, which is the largest value. So that you know that the maximum value is D. So 6. Okay, on to the next page. We're going to go to number 10, which says find dy dx, which is just the derivative, if y equals sine cubed times 1 minus 4x. So then we're going to simplify this, which you can see we do right here. And it's y equals sine 1 minus 4x to the 3rd. So you can move the cubed that's found right here up to right here. And that's just going to make it easier to solve. And let me just erase that. Okay. And then we're going to have to chain rule it. So then when we take y prime equals, and you move the 3 to the front, so 3 times just the normal inside, sine times 1 minus 4x. And then you don't want to forget to take this and subtract by 1, the degree and subtract by 1. And then you're going to do times, and then you have to chain rule again, which is cosine times the inside, 1 minus 4x, times negative 4, which is the derivative of the inside. So you have to double chain rule there. It's kind of confusing. But then, once you simplify that all out, so negative 4 times 3 is negative 12. And then you want to put the squared back on the sign, just because that makes your answer choices available. So negative 12 sine squared 1 minus 4x times cosine of 1 minus 4x, which if you look, that is choice E. So then we're going to, no, okay. Number 11 says, suppose f prime of x equals x times x minus 2 squared times x plus 1, which is the following is true. So if you want to see where your critical points are, you have one at 0, 2, and negative 1. So I did the first derivative test right here. And when you plug it in, it says f has a local maximum x equals negative 1, and it wants you to see if that is true. So I plugged in negative infinity to negative 1, and then negative 1 to 0, 0 to 2, and 2 to infinity. And I used negative 5, negative 0.5, 1, and 5 as my test points. And when you plug it in, you have a positive, a negative, and then a positive and a positive. So when you check this out, it says f has a local maximum negative 1. And since at negative 1, it goes from increasing to decreasing, you know that is a max, so 1 is true. And then it says a local min at 0, and it does go from decreasing to increasing, as we can see right here. And then we know that's true. And then since it goes positive on 0 to 2, it is still positive on 2 to infinity, then it has no relative extrema. So we know that number 3 is true as well. So we're going to put E as our answer. And we see number 12 says Let f of x be continuous function defined by f of x equals x squared plus bx when x is less than or equal to 3, and 6 sine pi over 2x when x is greater than 3. So you're going to go ahead and plug in when x is 3. Even though it says when x is greater than 3 for 6 sine of pi over 2x, you still want to plug in 3. And then you're going to set these two equal to each other. So you got 9 here because I made x 3, so 3 squared plus bx, so 3b, and then equals 6 sine of pi over 2 times 3. And then on the left, we're still going to have 9 plus 3b right here. And then we just simplified a little bit, 6 sine times 3 pi over 2, because you do 3 times pi over 2. And then we're going to go over here and simplify a little farther. So you still have 9 plus 3b on the left, but we know the sine of 3 pi over 2 is negative 1 because it occurs right here, and the sine is the y values. So the y values of that degree is negative 1. So just 6 times negative 1. So 9 plus 3b equals negative 6. So then you're just going to move the 9 over to the other side, which I did right here. And 3b equals negative 6 minus 9. So 3b equals negative 15, and b equals negative 5. So b is our answer. On to number 13. It says, a stone is dropped into a lake causing circular waves, the radii of which increases at a constant rate of 0.5 meters per second. At what rate is the circumference of a wave changing when its radius is 4 meters? So first, it says the radii of which is increasing at a constant rate of 0.5 meters per second. So you know dr dt, because that's the rate, equals 0.5 meters per second. And you want to find dc dt when r equals 4, which dc is the circumference. And you know a circumference of a circle is 2 pi r. And you might also know it as pi times diameter, but you want to use r here so that we have common units. Common variables, I mean. And then dc dt equals, and then you just take the derivative, which the pi is constant, and so is the 2, so just 2 pi dr dt. And then we find dc dt equals 2 pi times 0.5, because right here we have dr dt equals 0.5 meters per second. So we're just going to plug that right in. So 2 pi times 0.5. And we end up getting, when you do 2 times 0.5, it just equals 1. So it's just pi meters per second. So your answer is A.
Oh my gosh.
Okay, number 14 says, the integral from 0 to 6 of x squared minus 2x plus 2 dx is approximated by 3 inscribed rectangles of equal width on the x-axis. Then the approximation is, so since it's from 0 to 6, that's your integral, and you have to have 3 triangles. So you're going to do 6 divided by 3, so your width should always be 2. As you can see right here, I had all my widths at 2. And then all you're going to do is take each point from 0 to 6, as I do over here, and plug it in to find your heights. And then you're going to take 2 and put it out in front, because that's always going to be the width of each rectangle. And then you're going to times it by each of your rectangle's heights. So the first rectangle right here, it has a height of 1. And then we have a height of 2. And then we have a height of 10. And then you're just going to do 2 times that, and you're going to get 26. So the answer is C. Okay, number 15 says the set of all numbers c in negative 1 to 1, satisfying the conclusion of the mean value theorem for the function f of x equals x cubed minus x on the interval of negative 1 to 1. So all you're going to do is you're going to take the derivative, so 3x squared minus 1, and set it equal to 0. And then you're just going to divide by 3, so x squared equals 1/3, and x equals 1 plus or minus the square root of 1/3, or just plus or minus square root of 1 over 3. So your answer is C, right here. Okay. So on number 16, it says the integral of 2 to 4 of d dt 3t squared plus 2t minus 1 dt. So your dt's are just going to cancel. So all you're going to be doing is taking the derivative, just the derivative of the inside. And so with the integral, so you're going to do 3 4 squared, because we always do the top first, plus 2 to the 4th minus 1, and then you minus, and then you do 3 times 2 squared, because that's the bottom integral, plus 2 times 2 minus 1, and then you're just going to simplify it all out, as I do right here. So 48 plus 8 minus 1, and then minus 12 plus 4 minus 1 equals 55 minus 15, so 40. So your answer is just going to be B. 17 says the integral of root x plus 3 dx. So all you're going to do is you're going to go x to the 3 halves, because I made this x to the 1 half, and then I added it, or when you multiply it times x, you add the exponent, so it gets x to the 3 halves. And then I also distributed the root x to the 3, so it's just 3x to the 1 half dx. And now we're just going to take the antiderivative. So you get 2/5 x 5 halves plus 2x 3 halves. And then it's plus c because it doesn't give you the integral. Like right here, it's just empty, so you have to do plus c. And the answer is then D.